Okay, so this was the table that I was trying to tell you about. Can I get that under there? Oh, here we go. This is what we're supposed to be looking at. It tells us about the height and the weight. So if you look here, we can see the height and the weight. So this is the chart that you guys would be using in order to determine the mother's blood volume. So the doctor or the nurse, whoever puts the order in, they have to provide the weight and the height of this woman if she's pregnant and if she just had a baby. We need to know her exact height and weight, and then we use that chart, or this chart here, to determine and predict. That's why it says table of predicted natural blood volumes in women. So how much blood would be on average in a woman if she is this weight and this height? So if she were to weigh 150 pounds and she were to be 68 inches tall, 68 here, 150 pounds here, you literally just go across to 68 and down from 68 here. Your estimated blood volume for this woman would be 4,273. So this is what it looks like. Whatever the height and weight that's given to you, you use this table and you use that to predict whatever total blood volume that would be. Okay, so this is what I was talking about. I said you draw the line from the height and the weight here, here, and match it up with whatever block that is. So that's pretty simple. This has to be provided to you though. You need this chart and you need the height and weight. There is no calculation for the woman's blood volume. There's no calculation. It's just looking at a chart like this. Now, it says down here, if the height and or weight of the patient are not on the chart, use the next larger height and or weight. So if I said she weighs 165 pounds, there is no 165. It only goes up to between 150 and 160. So if she were 165, if she were 100, it goes between 60 and 70, sorry. So if she were 165, we would round up to 170. If she were 69 inches, we would round up to 70 inches. Okay, you're always going to round up if the number isn't on the chart. We want to overestimate instead of underestimate. Okay, so that's what the chart is. And now for the actual calculation, I'm going to do it out for you guys. So for the, basically what we're doing is we're calculating oh, there's hairs all over this. It was on the floor with the dogs. We're calculating first the, basically the feto-maternal bleed. It's a bleed. So it's whole blood. Okay. So the feto-maternal bleed, and if it's a bleed, we consider it whole blood. And the way we calculate the full fetal-maternal bleed, we call it a fetal bleed on that in the PowerPoint. So we're looking for mils of fetal bleed. That's what's on the PowerPoint. It's the same thing. So fetal-maternal bleed is in whole blood. And we know that RhIg 1 vial equals 30 mils, covers 30 mils of whole blood. Okay, so this is what we're calculating so that we can determine how many vials we have to give. That's the whole point of this calculation, and it's the whole point of doing a Kleihauer-Becky stain. So that's what we're looking for. That's what we're doing. And so the first thing that we need is to go under the microscope. We need to make a slide. We need to stain the slide. This all goes in like hand in hand. Actually, I'm going to go back one more step. Do we care about the fetal-maternal bleed Do we care about the Kleihauer-Becky result if the mom is Rh positive? Do we care about Kleihauer-Becky? No. We do not care if the mom is Rh positive. We don't have to do any of this. We're only going to do any of this if the mom is Rh negative and if the mom delivers a baby who is deemed, which we would test from the cord sample, Rh positive. If the mom is Rh negative and the baby that was born is Rh positive, then we're going to do a Kleihauer-Becky. If the mom is Rh negative but the baby is Rh negative, then we don't have to do a Kleihauer-Becky. If the baby is Rh negative, we do not do a Kleihauer-Becky. There is no point because we're not going to give RhoGAM. We don't care about protecting the mom from the baby because the baby is Rh negative and does not have any Rh positive antigens on them, which means there will be no risk of developing a true anti-D. So we're only going to do this stain and this workup and this calculation if the mom is Rh negative and the baby is Rh positive, or if the baby is weak D positive. So they may originally present as Rh negative, but when you do the weak D, they show that they're weak D positive. So if at any point they resemble Rh positive in any way, then again, you're going to do this Kleihauer-Becky test. So either Rh positive baby or weak D positive baby. So we obviously have to do a weak D on all of the Rh negative babies that are born. So if the baby is born and at immediate spin, they look like they are Rh negative, that's fine at immediate spin, but we 100% of the time are going to perform a weak D on all Rh negative cords. 100% of the time you're going to do a weak D. If the weak D is negative, then the true Rh result is Rh neg. If the weak D is positive, then the true Rh result is going to be Rh positive. What do we do? Can you see that? Rh positive. What do we do with Rh positive cords? We have to do Kleihauer. Okay? So baby gets born to an Rh negative woman. If the baby's Rh positive, easy, we're going to do a Kleihauer. If the baby's Rh negative at immediate spin, we are 100% going to do a weak D test. If the weak D is still negative, then they're deemed Rh negative. If the weak D comes up positive, we're going to call them Rh positive and then go back and do the Kleihauer. Otherwise, we'll go right into it. We're doing this Kleihauer test on Rh negative mothers who deliver Rh positive babies or weak D positive babies. We do not care about the Kleihauer if the mother is Rh positive or if the baby to this Rh negative woman is Rh positive. Is Rh negative. Because the whole point of doing the Kleihauer stain and then calculation is to determine how many vials of RhIg the mother needs to get. That's the whole point of this. Okay, so the calculation is the Kleihauer-Becky number multiplied by the maternal blood volume. That's the calculation. This number comes from counting cells. For example, 8 out of 992. Oh, sorry, you can't see that. Trying to do this with a tripod. So the Kleihauer-Becky number is achieved by counting cells, for example, 8 cells out of 992, and you have to actually do that math. You have to do 8 divided by 992. And then the maternal blood volume comes from chart which is this, where you're given the height and the weight and you figure out which number equals the maternal blood volume. So this is not calculated. This is just determined by the chart. So height and weight on chart. And that gives you your result, your maternal blood volume. So that's the equation. It's your Kleihauer number times the maternal blood volume. It's very simple. So if we were to count 7 fetal cells, let's still a moment. If we were to count 7 fetal cells, then our KB number would be 7 over 993, which equals, oh, I can't use my phone, 0.007 something. 1 second. I have an old school calculator. Look how cute that is. Okay, so your KB here, your KB number would be 7 divided by 993, which equals exactly 0.0070493, whatever. So your KB number is this number. Your KB number is not 7. Just because you counted 7 fetal cells does not make that your fetal cell number. Your KB number. Just because you counted 7 fetal cells does not make that the KB number. The KB number is 7 divided by 993, which equals this big number here. Well, tiny number, long number. This is your KB. And then KB times your maternal blood volume, which is from the chart. So if we were told that the mother was 170 pounds and she was 70 inches, we would go on the chart and we would go down to 170 and go over to 70 inches, and that's our answer, 4,740. So based on being 170 pounds and 70 inches, your maternal blood volume would be 4,740. So you would multiply your KB number, which is this decimal, by 4,740. And that equals so this number multiplied by this number equals 4,740 equals 33.41 da, 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 da. So this is our feto-maternal bleed in mils. If this many cells got into a woman with this blood volume, the feto-maternal bleed calculation would tell us that she had a 33.41 mil bleed. That's the bleed of whole blood that could have gotten, that must have gotten into the mother. From the sample that we took, from the 1,000 cells that we counted, 7 of those were fetal cells, divided by 993, times her total blood volume. That tells us that there must have been a 41 mil bleed of whole blood into the mother. That's what that tells us. So now that we've calculated our feto-maternal bleed of whole blood that got into the mother, we can now determine how much RhOgam, how much RhIg does this woman require. So we do our feto-maternal bleed. I'm going to get rid of this. So, number of vials of RhIg, you have to do your feto-maternal bleed in mils divided by 30, because one vial covers 30 mils of a bleed. So our feto-maternal bleed was determined to be, after all of that, 33.41 divided by 30 equals 33.41 divided by 30 equals 1.1136. And what did I say? If it's greater than the number 1.000000, if it's greater than that, you round up to the next whole number, which would be 2 vials. Does everybody see that? That's the calculation. So let's do another one. Okay, so the simple calculation of it is the KB number times the maternal blood volume and that's going to give us our feto-maternal bleed, or mils of fetal bleed. Same thing. So your Kleihauer number, your Kleihauer-Becky number, multiplied by your maternal blood volume is your fetal maternal bleed, or your mils of fetal bleed, however you want to say it. And then how many vials? Of RhIg? You do fetal maternal bleed divided by 30, because one vial equals covers a 30 ml bleed. So for whatever your volume is, you have to divide it by 30 and then round up. That's the calculation. Your KB number multiplied by your maternal blood volume will give you your fetal maternal bleed. And then you do your fetal maternal bleed divided by 30. It's actually very simple, but it's knowing when to use what. So if I said that we took a smear of the mom's whole blood, we made a smear, we fix it in ethanol, we put it in an acid, McKelvein's buffer is what we used, put it in an acid, the acid's going to remove the hemoglobin from the mom's red blood cells, but the red cells remain. The fetal cells are the hemoglobin is going to be resistant to that acid, so the fetal hemoglobin stays. Then we're going to stain it with safranin or eosin, and the fetal cells will show up as a nice bright reddish pink color. And we count them against the ghost, with and amongst the ghost mum cells in the background. So you count them. Out of 1,000 cells, how many of the 1,000 are fetal cells? So if you saw 3 fetal cells, that would be, we want to do KB times maternal blood volume. So 3 fetal cells would be maternal blood volume. Your KB number would be 3 divided by 997, multiplied by the maternal blood volume. And we'll say her height and weight is 165 pounds, and her height will be 65 inches. That has to be given to us. So we go to our chart and we look for 165 pounds, 160, 170. There is no 165, so we round up to 170. And then 65 inches, 66, or 64 and 66. There is no 65, so we don't go down the middle. We round up to 66. So 170 over to 66 is 4,416, right here. Based on this. So, sorry, you can't see that. There. So, we did our KB times our maternal blood volume, so our KB times maternal blood volume, we saw 3 fetal cells. So you have to do that slide count first. 3 fetal cells, so 3 divided by, out of 1,000, there was 997 left that weren't fetal cells. Multiply it by the maternal blood volume, which is 4,416. And that equals 3 divided by 997 equals 0. I don't actually do this in the calculator. I do them at the same time. So I do, if you can see that, I do 3 divided by 997 equals 0.003009. That's our KB number. Right here, 3 divided by 997, and it says times 4,416. So multiplied by 4,416. I just do it all in the calculator at one time. And our answer is 13.2877, whatever. So 13.2877, da 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 da. So that is going to give us our fetal maternal bleed. Because the KB times maternal blood volume is the fetal maternal bleed. So we did KB times KB times maternal blood volume is our fetal maternal bleed. And then what did we say? How many vials of RhIg do we need? You do your fetal maternal bleed divided by 30, because 1 vial equals 30. So our fetal maternal bleed is 13.2877 divided by 30 equals 0.4429, blah, 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 blah. If it's not a whole number, we round up to a whole number. So if we round this number up to the next whole number, it's going to equal 1 vial. And you can kind of guess in your head before you do this math, like if your fetal maternal, if your fetal maternal bleed is less than 30, you're only going to need 1 vial. If your fetal maternal bleed is greater than 30, but only by like a little bit, like 31, 32, you're going to need 2 vials. So you can kind of guess, but you still have to show your work on how to do it. There. So that is the math. It's the calculation you have to know, which is simple. It's one number multiplied by another number, and then that answer divided by 30. It's very simple. One number times another number gives you your answer, and then your answer divided by 30 is your number of vials. So simple. Multiply 2 numbers and then divide by 30. But you have to know where to get each number. That's the hard part. That's what people find confusing. Even though you're only multiplying 2 numbers together and then dividing that by 30, you have to know where the numbers came from. So where did the KB number come from? It came from the number of cells that you counted under the slide divided by the remaining amount of adult cells. So your KB number comes from 3 divided by 997. So you have to do a division first. You do have to divide 3 by 997 first. So 1 division multiplied by a number that you find in a chart, but you have to know that you have to go to the chart. That's something you have to know to do. Again, you have to know how to find the numbers to plug into the equation. So how do you get your KB? You count fetal cells against how many other adult cells are left. Count up to 1,000 and then divide the 2 numbers. Where do you get maternal blood volume? From the chart based on her height and weight. So just multiply those numbers together and then divide by 30 because that's how many vials are protected, or that's how many mils are protected by 1 vial. So it's very simple, but you have to know where the numbers came from when you had to plug them into each spot here. Okay. I think that's all I really wanted to say about that. Hopefully that all makes sense to you. This number will change every time, KB. Your KB number will be different based on how many fetal cells you counted under the microscope. So that will change. And then the maternal blood volume will change based on that particular patient. How much does she weigh? How tall is she? So those numbers will vary, and you have to know to divide your fetal cells first by the remaining adult cells. So it looks like a lot, but it's actually very simple. You just have to know where the numbers came from. How do I get the numbers? Which numbers do I plug into what part of the equation? And then divide by 30. Okay? That's it.